Hi, welcome to tutorial 3 on the MitMac Games channel. Today I'm going to be talking about scripting in Unity. Now, scripting is basically writing computer code, and writing computer code can be pretty complex. But learning to code really requires a couple of different aspects. One is just the syntax of the language itself. Second is putting all that syntax together in order to make your game actions do what you want them to do. And this can kind of be compared to learning to write a novel. So if I'm learning to write a novel, first of all, I need to know the syntax of the language. I need to know nouns and verbs and adverbs. I also need to have a large vocabulary. I need to know more than one word for sad or happy in order to write a good novel. Once I learn these things, I need to know how to put all these things together in order to make a good story. Now that may involve learning how to develop a plot, character development, scene development, and all the other aspects of learning to write a good novel. Then I have to have a great idea for an interesting idea to write about. So learning to code is not unlike learning all these things. Now, that requires knowing a lot of information. There's a fair amount of syntax to learn and understand. Unity scripts all use the C# language. So learning the syntax of C# and what that's all about. Learning the Unity classes themselves, which are all the things you can use in order to interact with your game development. And then knowing how to put all these things together in order to achieve what you want to do in a game. So instead of doing a lot of tutorials to go over all the syntax pieces and all the classes and learning that, what I'll be doing is doing a lot of game examples. And just like learning a new language, you learn best through using it. So I'm going to be using all these aspects and kind of explaining as I go these concepts so you can learn them by using them and seeing them used over and over and over again, and you practicing that yourself, I think is the best way to learn and expand your knowledge of the scripting language and being able to use it to achieve what you want in your game. So let's get started. All right, what I have here is the Unity project that we've been using for tutorial 1 and tutorial 2. And if you're just finding this and you want to know how this is all set up, you can go back to one of those other tutorials. And what we've done here is we have our arrow that we imported, we have our plane, and if you watch the other tutorials, you'd know that each square of this blue plane represents a 1 meter, what I'm calling 1 meter size square. So then we can use it to gauge how fast things are moving as we start moving around objects using our scripts. So we have our materials, we have our meshes, we have our images. What we need to do is to start creating scripts. So before we do that, what I'm going to do is I'm going to right click on this and I'm going to show in Explorer. And the reason I'm doing this is what we can see is on my hard drive, I can see where all of these files are stored. And what we can see is my assets folder and a bunch of other things that Unity added for me. And we'll see in a minute why I did that. So now let's go back to Unity. And what we're going to do is I'm going to create a new folder. Create folder, and I'm going to name it scripts. All right. And now in this scripts folder, wait a second, I'm going to create a new C# script. I'm going to name it create arrow. So the first thing we have to understand is that a script doesn't do anything by itself. A script needs to be added to a game object. And in this case, I don't have a game object really to add it to. So what I'm going to do is I'm going to come over here to my sample scene. I'm going to right click and I'm going to create empty. Might have wondered why I would want to do that. And I'm going to call this controller. And really this game object, it's not going to appear in my scene. It has no mesh, it has no material. It's just an empty game object. What I'm going to do is I'm going to move this game view over here. And I'm going to come in here and I'm going to add a component. And I'm going to click on scripts. And you'll see that there's some default scripts that Unity adds. And here is the script that I just added. And I'm going to click on it. So now our create arrow script has now been added to my game controller. And I'll explain why you need to do that in a minute. But now what I want to do is I want to edit this script. So when I select it here, I can see my script over here. But what I want to do is edit this script with Visual Studio. So you should have installed Visual Studio Community Edition before watching this video if you want to follow along. What I'm going to do is I'm going to double click on my create arrow. And what it's doing is it's launching Visual Studio. It's going to do a couple things besides just launching Visual Studio. So I see my script. And now let's go back to the folder that we looked at before, Game Tutorial. And you'll notice there is now added files to that folder. The one is gametutorial.sln. That's a Visual Studio solution. So Visual Studio is what we're going to be using for editing and building our Unity game, basically. And under Assets, we can see that there's a scripts folder, and here's where it created my .cs file. That's what I'm going to be editing, and Unity always creates a secondary file with the .meta extension. So let's go back to Visual Studio. We can see what it did is it created a framework structure for us to work in. First of all, it created my class name, which is usually always the same name as the CS file, called create arrow. You'll see this little colon and then this mono behavior. So the first concept when doing C# programming is that everything lives inside of a class. A class is a thing that does stuff for us, basically. And a class can be based on another class, in this case, mono behavior. And mono behavior is one of those things that Unity gives us, and it's one of the more important classes. And all my classes for my scripts are going to be based on mono behavior if I want to use them to control objects on my screen. It's a simplistic explanation. This using is other things that we need to use from Unity. And what it's giving us is two functions, one called start and one called update. And you can see from their comments, so these double slashes are always what we start to do a comment. This is just code for, or text for us to look at, us being the writers, not the compiler that's going to use this code. And start is called the very first time when this script is going to be run. And update is called once per frame. So Unity generally tries to run at 30 frames per second. So this update generally will be called at 30 frames per second. But depending on what you have going on your scene and how complex it is and how fast a person's computer is, it could be called a little faster or a little slower. You really don't know. So what we're going to want to do when this starts is we are going to want to create an arrow. So the function that we want to use, and again, this function comes from mono behavior. One thing, when I base my class on this class, I inherit, or I get to use all of the functionality that's in MonoBehavior, and one of those is called instantiate. So you'll notice as soon as I started typing, Visual Studio has what's called IntelliSense. So it's going to pop up a list of all the things that it knows I could use. And this is very, very handy. You generally never have to type the whole word of anything because IntelliSense is going to pop up and let you select. And in this case, I'm going to click this instantiate. I'm going to start with a bracket because this function needs parameters. It needs information that it's going to use in order to do the functionality that was programmed to do. And in this case, there are many different versions of this same function. So in C#, you can what's called override the functionality of a function, and it depends on what parameters you're passing into it, depends on which version of that function it's going to use. And in this case, what I want to do is I want to use this one. I want to pass in an object that is going to clone or copy. I want to give it an initial position, and I want to give it an initial rotation. Rotations can be confusing, and I'm going to be doing some tutorials later explaining all that. But for now, just know that we're going to use just a base quaternion in order to set basically no rotation when we do this. So as I'm writing this code, really what you have to be thinking about is 4 things as I decide what code I want to write. One is, what do I want to do? And in this case, I want to create an arrow. What information do I need? And in this case, I need to know an object. I need to know what arrow object I'm going to use. I need to know where I'm going to put it on the screen. And I'm going to need to know what rotation I want to give it. So I need data. And that data needs to come from somewhere. And it can come from various places. And I'll be explaining some of those options as we go along. Then I want to execute that action. And I want to know what triggers the execution of that action. In this case, what triggers it is this start function. So I know this is going to be called once, and it's going to be called when my script first starts running. So the first thing we do is we need to know, where am I going to get this arrow object from? And generally, the way you get it from is whoever sets up the scene needs to give it to us. So what we're going to do is we're going to come up here and we're going to create a variable that can be accessed through the Unity interface. And how we do that is we start with a square bracket. We start to type serialize, and we can see a couple options come up, and we want serialize field. This tells Unity to show this, whatever variable that I'm going to type in, it's going to show it in the Unity interface. Now, part of the syntax of the language are variable types. And I can make quite a few different variable types. I can have basic variable types, integers, floating point integers, which I'll get into, strings, which are just like text, or in this case, other classes that I'm going to use. And I have a bunch of classes that Unity gives me. And learning all these classes is quite a lot of work, and I don't know all of them in Unity. I know the ones that I've used, and when I need to use others, I do what a lot of people do, is I Google around or I look through the Unity manual. And in this case, the class I need is called GameObject. It's one of the most basic ones. We'll see IntelliSense pop that up. So I need a GameObject. Every single one of our objects that appears in a scene is a GameObject. And what I want to do is I want to give it a name that I can recognize. And names are very, very important. Making very clear, specific names are important. Don't use generic names. And I always make this mistake myself. I'm making a character, I'm making a robot character, and I call it robot. And then all of a sudden I make a second different kind of robot. What am I going to call this? Robot 1, Robot 2. It now becomes confusing as to which robot type I'm talking about. So let's be specific. And we'll call this one my arrow object. And then we always have to end in a semicolon. We got to tell the compiler, I'm done with this line of code. Now, naming syntax is also very important, and being very consistent of our naming so we can keep track of all of our variables. You can get a lot of different variables when you're coding up, and making some type of consistency is very important. And this is a typical one that most programmers use, and I use, is that these, what I'm calling a public variable, a variable that's accessed outside of my class, we generally start with an uppercase. So I'm starting this with an uppercase M, my arrow object. So now when I go to instantiate, I can use my arrow object as my first parameter. So the second thing I need is a position. And in Unity, if we're in a 3D game, all positions have an XYZ component. And that class that we use to specify that is, as you can see on the screen, vector3. So I'm going to make a new vector3. So this is going to create a new instance of this vector3 object. And that's very important to understand, that in order to use something, I need to create an instance of it. And that's different than a reference, and I'll talk about that in a minute. But I'm going to make a new vector3, and I am going to give this a position. And let's just, for now, type in 0, 0, 0 as its position. Now I need to add my last object, which is my rotation, and I want to give a 0, 0, 0 rotation. And so how I do that is I type quaternion, put in a dot identity. This basically says I want a rotation, and in this case the quaternion represents the rotation, and they're quite complicated, and I'll go into that again in future videos, but for now we just use quaternion identity is basically no rotation. So basically when this starts, it's going to instantiate a new arrow object that I've given it. It's going to put it at position 0, 0, 0 and with no rotation. So now what I'm going to want to do is I'm going to want to build this. And we technically don't have to build it in Visual Studio. We could just save it, but I usually always build it. And what it's going to do is it's going to save all my changes and build it. And when I build it, any errors that happen are going to be shown down in this output window. And in this case, I have no errors. I have one succeeded build, which is good. Now I'm going to go back to my Unity project, and you'll see that Unity detected that I made changes in my script, and it's going to build it itself and link it all into its environment. And then what I'm going to do is I'm going to get rid of this arrow here. I'm going to select on my controller, and what we see is I can see my script over here, and now what I see is my arrow object, what I named it. And you'll notice that when I named it, I have no spaces in between my text. And that is a requirement. Any variable name cannot have spaces. And we generally use upper and lower case to specify the words. And what Unity did was it added spaces before every capital that it saw. It's just a very common naming syntax that we use. But right now I have no game object. So what I need to do is I need to give it, what game object do I want to create? So I'm going to grab my arrow. Let's go under our meshes. I'm going to grab my arrow. I'm going to drag it in there. So now what my script is going to do is it's going to use this arrow object and it's going to create it right at 0, 0. And what I did is I put these numbers here to represent the coordinates on our plane here. You can see 0, 0 is at the center. It's not at the lower left-hand corner. It's at the center of my plane. So this lower left-hand corner is -50, -50, and this upper right-hand corner is 50, 50. Those are the coordinates of those places on my plane. So I'm going to do is I'm going to run my application. And after running, you can see basically what it did is it created an arrow. And there it is. You can see it's over here in my scene. Not very interesting, but it's a start. So if we hit this play button again, what it's going to do is it's going to stop it. And we can see our arrow disappeared because the arrow only existed while we were running our scene. All right. So let's make our scene do something a little more interesting. I really don't want it to create it at 0, 0. What I want to do is I want to create it down here. Let's move this out of the way. I want to create it right here. So I want to create it at, this is the Z direction. Remember the blue is in the Z direction, the -50 in the Z direction, and I want to create it at Y0, X0. So let's go back to Visual Studio. And instead of at 0, 0, 0, I'm going to make it 0, 0, -50. We'll build that. Come back here. And doing things step by step, I found is very useful. If you're not sure exactly if something's going to work, if you do 10 different things and it doesn't work, you have no idea which one of those broke it. So I like to do things in very discrete steps, do each step individually, get it to work, and then move on. And we can see it appeared correctly. Now you'll see it's like kind of half sunk into our plane because the center point, remember, is at the center of our object. So if I wanted to sit on top, I'd actually have to make a Y value that's a little higher, basically half the thickness. I really don't know how thick this is because I didn't pay attention to that when I brought it in. But it's not necessary for now, but just wanted to point that out. So let's stop this again. So now what we're going to want to do is we want to move this arrow. So let's do that. So let's select this. So every time we get an update, what we want to do is we want to adjust the position of the arrow and make it go forward. And this is one reason why I spend so much time on tutorial 2 on getting our object into Unity pointed in the right direction, because positive Z direction, which is generally what we're always going to want to move in, we have to make sure our object is pointing in the correct direction, which is the positive Z direction. So what we're going to do is every update I want to move this, but how much do I want to move it? Remember, this update, I don't really know how many times per second this update is called. So what I'm going to do is I'm going to make a new variable. This is a local variable. So I didn't talk about this before, but really variable scope, what we call variable scope, is dependent by these curly brackets. So you may wonder, why is there curly brackets around everything? I have curly brackets around my class, and you'll notice there's dotted lines connecting these two so we know how they line up. I have curly brackets around each function, and the curly brackets denote what we call variable scope, meaning who can see and access that variable. And variable scope is defined by the curly brackets. So this my arrow object, anybody inside these curly brackets can access my arrow object, but the only code inside of these curly brackets can access this, what we call a local variable, versus this would be called a member variable, meaning it's a member of this class. So I'm going to make a local variable called Z position, and I'm going to make Z position what I want to do is I want to move this, the position of my arrow. So I want to take the current Z position and I want to add to it. So I'm going to make Z position equal to transform. So why did I type transform? Well, transform is actually a variable off of GameObject, and it's going to use the transform of the GameObject I'm attached to, unless I specify a different GameObject. And the fact is what I want to do is I want to know the position of my arrow object. So I'm going to do is I'm going to make another member variable, and I'm going to call this going to be another GameObject, and I'm going to call it my arrow object lowercase. You'll notice this has a lowercase, and actually I'm going to put an underscore in front of it. This is another naming convention that's typically used, is that we always use private or variables that only this class can see. We're going to start them with an underscore and usually with a lowercase letter. And what I'm going to do is I'm going to copy this. I never type what I can copy and paste. And you'll notice that this instantiate passes back the instance of the GameObject that was created. You'll see in this pop-up, the GameObject that's listed on the very far left is what's returned from this instantiate function. And I want to save that because I need to use it. I need to use it later. I need to use it down here in the update. This is what would be called a reference, because this is simply pointing to or referencing the instantiated object. This instantiated created a brand new object. This simply is pointing or referencing that object. Hard to wrap your head around, and the more you use it, the more comfortable you'll get with some of these concepts. So what I want to do is I want to use this GameObject. I want to get that object, or my arrow that I created, I want to get its position. So I'm going to use that object, dot transform. Transform has a bunch of other things in it, and IntelliSense tries to guess what I want to use, and position is usually number 1, and I want to use its position, and I don't want to use its whole position, I just want to use the Z component of its position. So I'm going to make a variable. Now ZPos is the current position of my arrow, and now I want to move it forward. So I want to add something to it. But what do I want to add to it? I'm going to use this plus equals. Basically what this is going to do is it's going to say take Z position. This is a shortcut for taking whatever Z position is and adding something to it. So what I want to add to it is a distance. But I want to make that distance based on the time because I want to move it at some rate, right? And a rate would be, in this case, meters per second. We're calling each one of our units meters, so I want to move it in a certain amount of meters per second. And so what I want to know is how much time has elapsed between the last update. And Unity gives us this very handy function that we use a lot called time. And what I want to use is I want to use this delta time. I can get just the actual time of day. I can get the amount of time that's elapsed between the last update, which is what I want. And what I want to do is, if I just use delta time, it's going to move at 1 meter per second. And our whole plane is 100 meters long, so it would take 100 seconds to travel the whole thing. Kind of slow. So what we're going to do is we're going to multiply that. We use the star to represent multiplying. And we're going to take the current delta time and multiply it by 5. Again, this time is in seconds. So if delta time was 1, that would be 1 second. So what I'm going to do is I'm going to change my Z position, but I haven't actually changed the Z position yet. What I need to do is I need to take my arrow object, dot transform, and I need to give it a new transform. So what we can do is vector 3 also allows plus equal. It's a very handy function, and how it works is complicated, and you don't need to understand it. Just know that you can add to the position, not the transform, the position by creating a new vector 3, and I don't want to add to the x or y, I just want to change the z position. So we'll do this. All right, so now we have our arrow object. We're modifying our position. Let's build that. Let's go back to Unity. Let's let it reload and update its scripts. And now let's play. And we see a issue that it did not run. And one thing that I need to do is I forgot to add back the console window. So let's go in here. Let's go to General, Console. Let's just drag it down here. And we can see that there's an error in our code. And the problem is the position is incorrect. So let's stop this. This gives us an opportunity to show how to debug our code. So what we can do is in Visual Studio, we can actually set breakpoints so we can step our code. And whenever doing anything complicated at all, it always helps to step your code. So let's I just clicked in this column over here and it put this red dot, and this is a breakpoint. So what I want to do is I want a breakpoint on this to try to figure out what possibly is incorrect in our code. So I don't need to build, but you'll see this option up here, attach to Unity. What I can do is I can click that. Now what it's going to do is it's going to allow my code to be stepped by Unity. And you'll see it immediately stopped at my update. Remember whether I was still running or not. But we can step and see what is wrong. And we can see that my current position for my arrow object is extremely small. You can see that pop up. Or actually, it's extremely large. Let's step this. So it's going to show us the values of our elements, and Z position right now is, it's a extremely small number. What I'm going to do is I'm just going to stop this. This is where two screens come in handy. Let's stop this. Let's go back to our code. And one thing I do is if something's not working is I comment out code, but in this case what I'm going to do is make sure that, let's get rid of this. Let's attach to Unity. Let's go back to our Unity. Let's run. Let's click back here. See our initial position, 0, 0, -50, and that is exactly correct. My delta time is something very small. It's step, step. My Z position is now -49. All right. Took me a couple minutes to figure that out, but the issue with what we did was that we were computing the new position. I didn't want to add the new position to the old position. I wanted to reset the new position in order for my new arrow object's position. So I didn't need the plus equals. I just needed equals. I've done this various ways at different times. Sometimes I add the difference. Sometimes I create a new one. Really doesn't matter which one you use. But it is working now. And so what we can do is we can go back to Unity. We can run and see the result. And the result is that it created an arrow and it made it move at basically 5 meters per second. You can see it cruising across. The thing is that you'll notice that we can interact with it while it is in our scene. You can see my mirror one over there, or my camera one, which is the game view, and you can see my scene view. You can see it's just going to keep going forever. So let's stop this, and I'll show you some handy debugging tips that you can use while debugging your script. So let's run it again. And I use this a lot. I'll zoom in and I can actually select this, and I can actually see its position over here in the inspector window, and I can see its position is moving. Its Z position is moving. Right? So if ever something happened, like even if it's off the screen, I'll deselect it. It's off the screen and I have no idea where it is. I can go over here into my hierarchy. I can select the arrow and I can see its position. It keeps moving. It'll just keep going forever and ever and ever and ever and ever. So let's stop this. So if we don't want it to keep going forever and ever and ever, what we're going to do is we are going to destroy it or remove it from the scene when it reaches the edge of our plane. So let's go back to our script. And after moving it, what we're going to do is we are going to add a conditional, an if statement. This is another C# syntax. So we say if, and we have to give it a condition. And if my arrow dot transform dot position dot z, because that's what we're changing, is greater than 50, meaning that's the other edge of our plane. What do I want to do? What I'm going to do is I'm going to add some curly brackets, and in some cases this isn't needed, but it's generally a good idea to always encapsulate all of our code inside of our if in the curly brackets. We're going to want to do something. What we're going to want to do is we are going to want to destroy this object. Destroy is a built-in function in our class, and we're going to want to give it a game object, and we want to destroy my arrow object. The problem now, though, is that this update is going to continually be called every time, whether the arrow object exists or not. And as soon as the arrow object doesn't exist anymore, this line of code right here is going to not work anymore because arrow object is not going to exist. So we can do to point that out is we're going to go back to Unity. Going to run. Could have sped this arrow up a little more so we didn't have to watch it. Remember, I can click on it. I can see its value. I can actually pause it and actually modify this if I wanted to. And when it hits the edge here, what it's going to do is it's going to start throwing errors. And let's just stop this and read. It says missing type object has been destroyed, but you're still trying to access it, which is correct. I destroyed it. It's gone, but I'm still trying to access it. So let's fix that. So I didn't stop at my breakpoint because I didn't hit this attached to Unity. So what we want to do is we only want to do this code if my arrow object does not equal null. Null is a keyword used for basically nothing. It's empty. It doesn't exist anymore. We're going to wrap all of this around that. And we'll notice as soon as I hit this bottom bracket, it indented everything for us because we always indent to note that it's inside of this if statement. So now I'll build this again. Let's go back to Unity. And you know, before I do that, what I'm going to do is I'm going to speed this up a bit more because I don't want to have to wait so long. So let's give it a 10. Let's make it go twice as fast. Now let's run. There it is, moving twice as fast. That's good. You'll notice it can go right through those zeros. Did it not build? Nope, because there was one thing we missed. We're also trying to access this arrow object here, aren't we? So what we can do is we can do one of two things. We can move this, so we'll do Control X to delete. We can move it all inside of this if. Let's build again. Let's go back to Unity. Run it again. Let's see if it works this time. Coding is a lot of trial and error. I've done this hundreds of times and it's still easy to make these mistakes, but that's why we have the console window to tell us what the errors are. And it's going to keep running forever, but it's just not going to be doing anything. So we'll stop it. We have the debugger here where we can set breakpoints. We can step our code. Very valuable to be able to use all these debugging tools. While in the scene, we can see we can interact with the objects in order to debug them. So I know there's a lot here. It's all very, very basic, but we're going to be building on these basic concepts in the subsequent videos. So thanks for watching. If you think this is useful, give it a thumbs up, subscribe to the channel, and I'll be moving on with lots more tutorials to keep building on this script that we just started. Thanks for watching.